Gases are made of particles, and when they move around and they hit the sides of a container, they exert a force on the container, and this creates a pressure. In this lesson video, we're going to look at this gas pressure in more detail, and we're going to see how it relates to the temperature of the gas. Now, hopefully you'll be able to do an experiment to test this all out yourself. The normal one would be to take a Jolly bulb, which is presumably named after Philip von Jolly, who famously advised the founder of quantum physics, Max Planck, not to go into physics. The Jolly's bulb is simply a round bottom flask with a pressure gauge. It is put into water and the pressure measured from the gauge. By changing the temperature of the water, a graph can be produced that can be used to find, amongst other things, the lowest possible temperature. I want to focus more on the cause of the pressure though. So, let's consider this can. It's got air particles inside and out, and as you can see, the particles are moving in random directions, hitting the walls of the container. Since they are on both sides though, the forces and the pressure they exert cancel out. Consider just this position here. If a particle hits the wall from the inside, it exerts a force F on the wall, pushing it outwards. If another particle hits the wall from the outside with the same force F, it will push inwards. The resultant force then would be F minus F equals 0, so the wall will not be affected. Moving on though, we're going to remove the air from the inside of the container using a vacuum pump. After the air is sucked out, the can has no particles inside it. Air particles outside the container still collide with the walls of the container. The force on the outside is greater than the force on the inside. So, if the walls are not strong enough, the container collapses. That's it, except for a better way to describe the force that is exerted by a gas. I skipped it a bit earlier because it's going to use some terms we're not really going to get into until next year in the dynamics topic. But here it is anyway. When an air particle collides with the wall of the container, it changes direction. This means that even though it bounces back at the same speed, its velocity changes because velocity cares about direction as well. If the velocity changes, then a quantity called momentum also changes because momentum is equal to mass times velocity. Finally, Newton tells us that the force exerted is equal to the rate of change of momentum. So, when the particle bounces off the wall, there is a change in its momentum, so there must be a force using that equation. We'll come back to that when we learn about momentum fully, but it just seemed right to mention it now. So, now we know how pressure is exerted by a gas, we can think about what the results of this experiment might be. What do you think? How will temperature affect the pressure exerted by a gas? Do pause this and think, and maybe also think about why. Well, as the gas gains thermal energy, its particles move faster. If they move faster, not only will they hit the walls harder, but they will also hit the walls more often. This means that the pressure will increase. So in this lesson video, we've looked at how to investigate pressure and also how to explain pressure in a gas. Do be careful with one point, that Although the particles in the gas are moving around, they're colliding with one another, we don't care about the collisions between gas particles. The only collisions we're interested in are the collisions with the container, because those are the ones that we notice on the outside.